Okay, here we are, 2.7 polynomial and rational inequalities. Rational inequalities. And what are we doing? We're solving these things. Okay, so solving. And we've dealt with the linear inequalities already, right? So, and we also dealt with absolute value inequalities. So it's basically just an equation, but now we have an inequality symbol, greater than or less than or greater than and equal to, less than or equal to sort of deal. Okay, and there'll be similarities to actually solving regular equations and dissimilarities. The biggest dissimilarity is the actual answer. When we go for our solution, we'll have an interval notation type deal. And okay, so let's get in here and take a look. So solve and graph. Solve and graph the solution set, and when they say solve, they want you to give your answer in interval notation. Okay, so interval notation, I need to see that on the test. Okay, so let's see what we have in example 1. 2x squared plus x greater than 15. Our first step is to get 0 on one side, and that's basically what you had to do when you solved quadratics. Okay, so it should feel similar. So what are we doing? We're setting 0 on one side. Okay. So simple enough, we're just going to subtract 15 from both sides. We get 2x squared plus x minus 15 greater than 0. Okay, what we're going to do now is kind of drop the inequality and solve it. Okay, so temporarily, we are dropping the inequality and solving. So we'll have 2x squared plus x minus 15 greater than 0. And then we'll have 2x squared plus x minus 15, equals 0, right? So we want this equal to 0. We're temporarily set. And what you're doing is finding boundary points for your intervals, okay, for your solution intervals. Okay, so we're going to factor it just like normal. Hopefully you can factor. I think most of these you'll be able to factor. Okay, so don't worry about it. 2x and 5 and 3, I guess. So 3, we need that to be positive, and then minus 5 and an x here. Okay, so 2x squared on the outer, 6x minus 5x, the inner is 1 positive x. Negative 5 times 3 is negative 15. Goes there. And so our boundary points, find these by setting these equal to 0. X plus 3 is 0. So x is 5 halves, and then x is negative 3. Okay. Once you do that, you're going to plot these boundary points on the number line. Okay, so step 3, plot these 2 points you just found, which I'm calling boundary points. I'm sure the book does the same. And you're doing that on the number line. Okay, so here's our number line. Here's negative 3. Negatives are to the left of positives. So we don't need to write every number. We're just going to plot the 2 boundary points. Okay. Okay. And on the left side, what we're going to do is kind of label our work. We need a test value, and what that is a particular point in this interval from negative infinity to negative 3. We want to test to see how the sign is going to work. Okay, so if it's negative, we'll know in that case this thing will not be greater than 0. Okay, if it's positive, then it will fulfill this inequality, and that's the interval we want. Okay, so that's what we're doing here. We're taking a test value, we're getting a sign, and then on top of that, we are making a conclusion. Okay, so pick easy test values, and because all you care about is the sign, you don't necessarily have to compute the value. So what am I doing? Okay, so I'm taking a test value. So pick something in this interval from -infinity to -3. So I'll pick x equals -5. Okay, that'll be my test value. Then I take this number, and you're literally plugging it into this guy right here, this 2x squared plus x minus 15. Okay. That's a lot of computation in your calculator or in your head. So you don't want to put it necessarily in there. You want to put it into this factored form. If you put it into this form, it's a little easier to figure out the sign, right? If you put -5 in here, it'll be -10 minus 5, which will be a negative. If you put -5 in here, it'll be -5 plus 3, which will also be a negative. So you'll have a negative times a negative, and a negative times a negative is positive. So you avoid having to do the hardcore mental calculations, unless you can do them in your head, and then good for you. Okay, but us humans, well, I shouldn't be like that. Us less cool people need to put them in our heads and actually chug them out. Right, and so our sign is positive, and our conclusion then is that in this interval, this polynomial will be will be greater than 0. Okay, so you can conclude, and that's good. That's what we want. So this interval would be in our solution set. Okay. Okay, so let's keep going. I need another test value. I'll pick x is 0. Okay, so an easy number to test in between -3 and 5/2 is 0. So I plug that in. You can plug it into the original polynomial this time. That's easy. It's just -15. So the sign will be negative. And in that interval, the quadratic will be negative. It will be less than 0. So we're not going to use that in our solution set. Okay. And then pick another test value over here. Say 5 again. Okay. So I plug that in here. 2 times 5 is 10, minus 5 is a positive, and then 5 plus 3 is a positive, so I end up with a positive. Okay? Right, so I want the intervals that have the same inequality as up here. Okay? I want to find where this is true, and I've done that. It's true in this interval and this interval. Okay? So finally then, in step 4, you're going to write up your solution set in interval notation. So in interval notation, -infinity to -3, and then union it with 5/2 to infinity. So these two intervals are our solution set. Okay. We don't use the bracket because of the type of inequality. If this was greater than or equal to, we would have included the endpoints. Okay. Okay. So that's the idea, and the general procedure is there for us. Let's try another one. Okay. Okay, so following the same procedure, I want to get 0 on one side. And maybe we should try with, let's change it a little so it's like this problem, but not exact. I'll put a line underneath the inequality, so it's less than or equal to. Okay, so 3x squared plus 16x, and then bring the 5 over, so plus 5 less than or equal to 0. factor it, right? So 3x, and over here is a 5, and then x and plus plus, less than or equal to 0. At this point, we could set it equal to 0, and well, maybe we should have done that above, but okay, you get the idea. So usually we want to set this one equal to 0, but 3x plus 1 times x plus 5, and then that's equal to 0. And then take the parts, and you're looking for the boundary points. 0, so x is -1/3. X plus 5 is 0, so x is -5. Do your number line. So -5 is way over here. -1/3 is way over here. We need test values. We need signs. And we need some conclusions. So test value, let's try x is -6. You can't use the boundary points, okay? You have to use something that's inside the interval. And let's put -6 in here, so -18 plus 1, that's a negative, and then -6 plus 5 is a negative. Negative times a negative is positive, so my conclusion, it's above. Let's try x equals -2 for that interval. So -2 times 3 is -6, plus 1 is negative, -2 plus 5 is positive, so this would be negative, less than in that interval. And then finally take an easy number, 0. Plug that into here, you get positive times positive, of course it's positive. That'll be greater than 0. So the ones we want are, the intervals we want are the type that are less than 0. So we want the middle interval this time. And in particular, because of the inequality type, we're going to use brackets. We include the endpoints because that's exactly where they are, 0. Okay? So it'll be -5 to -1/3 as our solution, including the endpoints. Okay, solving rational inequalities is a little more complicated. You have to worry about the undefined points. Anyways, step 2, section 2, solving rational inequalities. And we'll start out with example 4. So I have x plus 1 all over x plus 3 greater than or equal to 2. Okay. And the first thing you want to do again is set the thing equal to 0, basically. Okay. And what are you doing? You're looking for boundary points. And the boundary points this time come from 2 places. They come from where the denominator is 0 and then also where the numerator is 0. Okay. So let's go ahead and do that. So first we are sort of getting 0 on one side. Okay, so I'm going to move the 2 over, and then I'll have a bit of algebra to worry about. I need a common denominator here. So 2 is the same as 2 over 1. And this should be a 0 right here. Sorry about that. And then I'm multiplying top and bottom to get a common denominator. So I multiply it by x plus 3. And then I'll have x plus 1 over x plus 3 minus 2 times x plus 3 all over x plus 3 greater than or equal to 0. Then I want to combine the numerators over the common denominator. So x plus 1 minus 2x minus 6 all over x plus 3. And I'm simplifying, so I'll have negative x minus 5 all over x plus 3. Okay, so at this point, I want to find the boundary points. Okay, so secondly, find boundary points, and it's a little different here, like I said. What you're doing is taking the numerator and setting it equal to 0. Okay. And then you're also taking the denominator and setting it equal to 0. Okay. This thing comes with a warning. The denominator can never be included. The number you get from the denominator, x equals -3, this can never be included in the solution set. So you're always going to have to end up using an open dot with it. Okay. So it needs a little open dot when you put it onto your number line. This one, however, is different, and it's dependent on the inequality. Okay, so this will be included because there's a line underneath the inequality, right? So this is exactly where the thing is equal to 0. So anyways, negative x is 5, and then x is -5. Okay. And just as before, we're going to plot these things on a number line. So we're plotting the boundary points here. Plot boundary points. So I'll have -5, which I'm including, so you may want to put a closed dot there to remind yourself. And you include it again because of this type of inequality. Okay, the line underneath means you include -5, x equals -5. Okay? And over here, this is indicating you never include it. Okay, so never include the answer you get from the denominator. So when I do plot -3 here, I'm going to remind myself with an open dot. Or you could use an open bracket, open parentheses, but you don't really know which way the parentheses should be going, so just use an open dot. Okay, at this point, you're doing your test value just like before. You're doing your sign, and you're doing your conclusion. And you should be going to this guy right here, the one that's has 0 on the other side. And we'll be plugging in our numbers. So we'll try x is -6. And the reason why I'm kind of putting it in a box is you don't want to confuse the -5 and the -6, right? I've seen people that put all kinds of tick marks on their boundary line here, and it just gets confusing. You really only should be plotting your boundary points. Okay. Okay, so if you plug -6 in there into this, you'll get -6 is positive 6 minus 5 is positive, divided by -6 plus 3, which is negative. A positive divided by a negative is negative, so that'll be less than. In this interval, let's pick x is -4. Okay, I'm plugging into here, so -4 is 4, minus 5 is negative, -4 plus 3 is negative, negative divided by negative is positive. Okay. And then over here, let's try x is 0. So plug 0 in here, you get a negative over a positive, so that's negative, and that'll be less than. So the interval we want is the one that has the greater than symbol. That's this middle interval. Okay, so write up our solution in interval notation again. And what do we want? We want this middle interval. So from -5 to -3. And then, because of the inequality type, we include -5. That's why I put that closed dot there. Okay, the line underneath the inequality means include -5. That's where this rational formula equals 0. Okay. On the other hand, though, you can't include -3. This thing is going to be undefined at -3, so you can't include it in the solution set. You'll have division by 0 there. Okay. One more, and then we want to do an application. So this is 58. And we have 1 all over x minus 3, less than 1. And we want to go through the same process. Right? So we'll go 1 all over x minus 3 minus 1 less than 0. Find your common denominator. X minus 3 minus 1 is the same as 1 over 1. So you multiply top and bottom by x minus 3. Right, so I'll have 1 minus x minus 3 all over x minus 3. And simplify, distribute the negative, 1 minus x plus 3 all over x minus 3. Negative x plus 3 plus 1 is 4 minus x, and then that's all over x minus 3. Now we want our boundary points, so you take the numerator, set it equal to 0. You take the denominator and set it equal to 0. And I'll remind myself, this one is not included. It turns out this time neither boundary point will be included because of the inequality type. But in this one in particular, I need to be very careful. It's never included. Okay? Anyways, x is 4, x is 3, and we'll plot those on our number line. Here's 3, here's 4. I need my test value. I need my, what else do I need? My sign and my conclusion. Okay. So I'll take x is 0. That'll work nicely. Plopping it into this equation, positive over negative is negative, so it's less than. Okay, so that interval is in the solution set. I'm not including 3 this time, and it's because of the inequality type. There's no line underneath, so we don't care where this thing equals 0. We just want it strictly less than 0. Okay, so I'm not including this point here. So this inequality type tells me not to include that. In the middle, I'll check x equals 3.5. So 4 minus 3.5 is 0.5 positive. 3.5 minus 3 positive. Positive over positive is positive. And then from 4 on, I'll say x is 5. Okay. So put in 5, I'll get a negative over a positive is negative. And again, we're not going to include this. And in particular, it's not because of the inequality type, it's because it causes division by 0. Okie dokie. So anyways, we'll draw up our conclusion based off this inequality. We want the less than intervals. So our solution will go from negative infinity to 3, not including 3. Okay. And then we're jumping over this interval, and then we're going 4 to infinity. Of course, not including 4. Okay, so let's try an application, and we're going again with projectile motion. So we have some physics, and this is number 76, and they give us a nice position formula. S of t is negative 16t squared plus v sub 0 t plus s sub 0. Okay, and I think we showed you this one before. It's when we talked about dropping the silver dollar off the building. I'll just remind us, I guess. So S of t is a position function. T is for time. V sub 0 is the initial velocity, how fast it's going in the beginning. Okay, so if we dropped a penny off a roof, it would be 0. And then S sub 0 is your initial position. So if I'm standing up on a roof, maybe like 60 feet off the ground. Okay, so initial position. Okay, the story problem then, we have a ball is thrown straight up from a rooftop. (160 feet high). So I assume the rooftop is 160 feet high. It's not talking about the ball here. With initial velocity of 48 feet per second. And they want to know during what time period is the ball above the roof. Okay, so a picture maybe is in order here. Here's our building. It has some windows on it, and there's somebody on the roof here throwing a ball up in the air. The height of the building is 160 feet, and the person is throwing the ball straight up, and then it's coming back down, right? So what do we want to know? We want to know during what time period is the ball in this region here, in this, from here to here. Right? Okay. They give us the initial velocity and the initial position and the story problem, so we need to fill in our formula. So the initial velocity is given as 48 feet per second. And then the initial height, or initial position, is this 160. Okay. We want to form an inequality here, and basically what we're asking is for where this thing is greater than or equal to what? Well, 160. Where is this ball above 160? So that's our inequality. We have negative 16t squared plus 48t plus 160. I'm just plugging numbers in to our formula from physics. Okay, that should be 160. And I'm trying to find out where that thing is above, so I want to say greater than 160. And then we just use the methods from today to figure this out. So I'm going to set it equal to 0. It may be easier to move the negative to the other side. It's up to you. We don't have to. So if we do, yeah, sure, let's do that. So let's move everything to the other side and set it equal to 0. So we're going to have 16t squared minus 48t. And then if I subtract 160 and 160, you get 0. But remember, you're on the other side of the inequality, so it would be less than 0. Okay. I'm going to factor out 16t, so I'll get t minus 3 less than 0. The boundary points then, so you're setting it equal to 0 and solving. 16t times t minus 3 equals 0. So you get two solutions, 2 boundary points. 16t is 0, so t is 0, or t minus 3 is 0. In other words, t is 3. Okay. So we'll go ahead and plot those down on our number line, 0 and 3. Right there, we have test values, we have signs, and we have conclusions. Okay. So our test values, we'll try x is negative 1. and plop that into this formula here is easier to work with than this formula, so or this formula. So let's try this one. Negative 16 times negative 1 minus 1 is negative times negative, so that'll be positive. Our conclusion, it's above, so we don't want that interval. And here, let's try x is 1. So plug in 1, and you get positive times a negative, so it's negative. Our conclusion is less than, so that's the one we want. Okay? And now let's try this one, x is 4. Positive times a positive is positive, it's greater than. Okay? And that's the dealio. It's this interval right here that we want. So from time t equals 0 to t equals 3, and that makes sense. You know, in the beginning, it's above the roof, he's throwing it straight up. 3 seconds later, it goes below. Okay? So during what time period is the ball above the roof? Okay? The ball is above the roof from time t equals 0 to t equals 3. Okay? And that's it, seconds. I guess we should put seconds there. Okay, that's it for this section. Goodbye.